So, good evening. Here we have today a small collection of parts ranging from 3/4 inch aluminum through some 1/4 inch steel, some 3/8 inch steel and aluminum, to some 1/2 inch stainless and some 3/16 aluminum. Everything but the 1/2 inch stainless, which you can see here, has dross on it, which looks pretty brittle. We'll see if we can remove it. It's a very nice and clean cut, so we should have no issues at all with just the DM1100C crossbelt machine for some good deburring and edge rounding. What we have on this machine here currently is our regular purple abrasive, which is ceramic, and it is a little bit more aggressive than the normal standard 40/60 grit blocks. This ceramic abrasive, which especially should make a difference here, is backed with what I said before, our purple fleece Scotch that also has abrasive in it and is a little bit more aggressive, especially on the outside contours. The 50 grit is not as flexible as a full purple grit abrasive, which I don't have here right now to show you a picture. We may see a little bit less of an effect on the inside contours with that. So to set up the machine, all we are going to do is I'm going to set it to 3 millimeters for the material thickness. I apologize. I'm holding the camera while I'm operating the machine. Why am I setting it to 3? Because I want to go about 3 millimeters below the surface of the material with these blocks. And then we are going to bring the blocks down. To about 50. And all we do is we turn the machine on. We turn the blocks down so we can hear better. And then we listen. When we hear the sound that the blocks are hitting the conveyor belt, that's when we know that we are 3 millimeters below surface. At this point, we go to the first material thickness. We'll go to 1/4 inch. For the steel, we try that first. And we go to full speed on the crossbelt. And we go to about 3 feet a minute to start out. It's always 1 foot more than what the potentiometer says. That's how it comes out. And we will just take this part. As you can see, the edge condition before, just a sharp edge, no real burr. This is the non-burr side. Here. And this is the burr side. We run this at 3 feet a minute to get a first impression of the result. As you can see, I run the parts diagonally. Now you already see the white line. And that is the edge rounding both on the small inside contour and on the outside. So then we bring the temperature slightly more. We could go a little bit harder, or we can run it simply slower. So we will mark this part. So that was 3 feet per minute and medium pressure. Right? And I just tried this here once. It's a P50 ceramic. So now we're going to do the same thing for these parts. They are all 1/4 inch here. Of course, especially important when you have a round part, like this one, but put it at 45 degrees. pressure on my belt, about a 1/2 millimeter, and we just let it go like this, and we can add right away. So that would be like a medium plus pressure, and we can run this right behind. Let that go. Part already did run, but these didn't. We're going to take this little one here and see how nice the part goes, and we are going to accelerate to 40. If you are happy with those results, you can run literally thousands of parts per hour on this machine, single-sided. So, and then we will take this part and we'll do exactly the opposite. We will go to about 2 feet per minute. So we go really slow. This part is like water. If you can see it on the video, but you can see how the brushes skim over the part. You hold it parallel to the belt. And of course now you have more brush time on the part as it moves slower. It's going to come out more. Now we're going to increase the pressure by another another millimeter. So we're going to go down to 44.4, half a crank. Okay, so now we have heavy pressure, and we're going to keep it at 2 feet per minute, right here for the 1/2 inch. But what we of course also need to do, we need to set this really quick to 1/2 inch. There you go. So you see how quick the setup of it. Changing between different materials, material thickness, giving it a little bit more, giving it a little bit less pressure, or slowing it up or slowing the speed. You literally only have one on-off button for the cross belt, one on-off button for the conveyor belt, the speed setting for the process is always on high when you run parts that will hold. Very small parts that have tendency to slip, you would slow that down. And then you have your potentiometer to control the speed of the conveyor belt. You can also now working a little harder. This is your display, how deep you are into the part. And these are almost new brushes. And new brushes, 50 millimeters. And then whatever you want to go into the material. And this is your material thickness. So now obviously everybody is going to be really curious what it looks like. And this is how the part came out. And you pretty much have all the burr removed. Have you feel that? No, you have a little bit less here. So this could require that you need to run this part for a white belt sander first. Remove everything here on this corner, not along the border. So, if we go around exactly, you can see how much debris we have here. Remove into the machine. So, now we're going to do the same thing from the other side, and of course you will see a completely different result as well. So, in order to remove dross before, all you need to do is lightly touch it on a white belt sander like this machine, and set it basically almost above the surface where you don't remove any material from the surface, you just scrub off the dross. For that, of course, it is important that the part stays nice and flat and normal, especially the plastic also dry. And here again you can see on the right line, you can see what kind of a radius we can make. So for the purpose of this sample, I will run that on the white belt sander and then run it again on the front. And maybe something that I'm going to do tomorrow. So this is the back side here. And what we have on this video, we have documented is just how little dross we have left. It is very round, you can't cut yourself. It doesn't feel bad at all, right? But it clearly is there. We could also just simply try to run it a second time, and that may already remove that. So anyway, here, this was the non-dross side. And we ran at 2 feet per minute, and we ran at plus pressure. All right, moving right on. Let's get going with the 3/4 inch aluminum, almost 20 millimeters actually on that part, 19.8. So we're gonna go to 19.8 here. Where setting is not super important. This we will back off again because for aluminum you really won't need that much. We go back to 45.9. We go to a medium, or a nice medium light setting. This keeps faster. For aluminum we can go a little bit quicker. We're going to go 4 feet per minute. And remember, this also has a little bit dross on this side, but in aluminum this will easily remove. There we can hear a scrub. And in aluminum this may even be too much. You may want to go lighter if you don't like how much indentation you have in the edge. There you see, nice radius all the way around. And we go to the other side. Exactly very small, so we would have gone a little bit heavier there, which I will do here now again. I'll go back to my 45.4, oops, the other way, 45.4, 3, 2. Of course, with a small part like this, you need to be careful that you don't slip it in the machine. This part is big enough that it does not move. No side fixes in the part. And also, if you want to get a little bit more, you could go a little bit slower. That is the result here. And actually, to duplicate that result on the burr side, what I will do, I will run that a second pass, and we'll go a little bit slower at about 30 inches, 2.5 feet per minute. So, again, always important is the script. So that was a burr side. And I like these videos because it documents exactly what we do, so you know how it came about. So this was 2 pass. The first one was 3 feet per minute, medium, and the second one was 2.5 feet per minute, medium plus. So my guess is if you ran that at 2 feet per minute at medium plus, you would get exactly that result in one single pass. And to prove that point, we go to that 3/8 inch aluminum, has a similar burr, 3/8 inch aluminum, has a similar burr, and then of course we have the 3/8 inch steel. We actually can run those both at the same time. So we put those on here, we leave that setting, we leave the speed setting, all we do is we adjust the thickness setting to about 9.5. 4.95, like that. This has a complicated inside contour, and it could be that if you want total consistency on the inside contour, you want to run it a second pass. Whoops, that part shifted a little bit. And that can happen with smaller parts because you're running a pretty heavy on the medium plus already wants to fit the smaller parts. Nothing more will happen. So here you have your aluminum, and here you have your steel. And you see this was very aggressive on the aluminum. So 30 inches per minute. And medium plus pressure. And that was also the same thing here. So, and then last not least, we are going to run, this is a 316, looks like a piece of scrap, so that's about 4.5, and we're going to run that at 4 feet a minute, which is 48 inches, quite a bit faster, but still with the medium plus pressure. realize that I didn't run the back side of those parts. The aluminum I'm actually going to run faster, at 48 inches a minute. So you see here, 48 inches a minute. And we're just going to repeat, this is actually the bird side here. Just going to repeat that on the bird side. With the paint results and something like that. And this part, because it is smaller, has some good temperature to it. I mean, we hit that hard. So, and I said I wanted to repeat this with this, the aluminum. So I'm going to go a tad lighter here, 45.9. I need to go to 9.5 millimeter here. There we go, and we wanted to go to, let's go, we stay at 4 feet a minute. And then we have the steel here. We are going to do the same thing here so that you see lighter results. Here's your aluminum part. So you see a smaller radius. Maybe actually you like this better. So that's 48 inches a minute. And a medium pressure. We have the same thing here. Easier to write if the thing is stationary. So, the last thing I want to do is I want to give this another try. I'm going to run this on the bird side again to see if we can remove this. Maybe, maybe not. So, I'm going to go back to 2 feet a minute. Really slow here. Full speed on the cross belt. We're going to go to our heavy setting, 44.4. We're going to go to 12.5, 12.7 for the half inch. And I can see, last time our grinding operation is this way. You can see the markings on it. We're going to go exactly perpendicular to that. Which means we're going to feed them into grain so that we get another result. At 2 feet a minute of a part like this, we're going to have about 1, 2, 3, 4 side by side. 4 of them going to disappear, so it's about 8 parts per minute per side times 60. So you're going to run about 480 parts an hour for one step. So even if you ran twice, 240, that would still be very good. So now you see we're starting to have real radius here. You have a little bit of a side cut on that. But that's the same now the laser cut. There's nothing that will eliminate that, other than maybe a deburring brush. We are now clean on the inside contour, reasonably. Okay. We have very nice surface. This is super clean. Second pass with the ceramic block of this part. So would be, and you would get a similar result if you ran it through a white belt sander first. So that's up to you. So that's 24 inches per minute, 2 feet per minute. We have a plus pressure, which is easy because in half-inch material you'll never touch the conveyor belt. So about 3/16 below surface, right? And we have 2 passes. And the 2 passes were perpendicular to each other. Okay, and that concludes our business for today. I will send those parts back to you tomorrow morning, so you should have them by Monday. Thank you very much.